Hey, hi everyone, and welcome to yet another episode of Leetcode Weekly. This is the third episode, and today we're going to take up this hard problem from Leetcode, which is minimum time to remove all cards containing illegal goods. A very big name. This is a really cool problem of multi-stage DP, and I'm going to talk about this idea in this video. And alongside that, I'm going to also move to one more problem apart from this one, so that you get this idea very clearly. So this particular multi-stage DP is more like a constraint idea where how do you model this kind of a constraints into a particular state. And this is a really cool problem and can help you to solve so many such subarray problems that are there in DP problems. Okay. And just like any other weekly videos, this also video has a particular target that makes sure that you kind of go back to this particular video's comment and comment out what you learned from this video. If you like this particular multi-stage DP, make sure that you write that up and let me know if you need more DP such problems. This week in the last atcoder problem also we talked about a nice way to formulate such DP problems. I'm planning on to take the codeforces problem as well in the DP format. So let's keep this week a DP week. Right? And without any delay, let's just get into the problem because this is a very cool problem. I'm not saying that this is a hard problem as such because there might be multiple ways in which you can solve them. But the idea that I'm going to explain you in this one, which is multi-stage DP, is really cool and can be extended to so many such problems, right? And in fact, I'm going to give you one such idea after this problem as well, a new problem. Okay, not the usual format, but still we will do that. Let's move into this. So you are given that there is a particular sequence wherein you have like a given string S, and there are zeros and ones in that, and based on that you will have to remove all the ones out of this particular string. And the way we can do that is by removing train cars from the left end, right end, and from anywhere in the between. Now the thing is, if you remove something from the right end, like if you remove these two from the left end and this one from the right end, each of these right end movements are costing us 1 unit of time, and anything that you remove from the middle is gonna cost you 2, right? So obviously you would not try to, like if you are removing things from the right, you would not like try and take out 2 cost movements over there, right? And we need to find the minimum time to remove all the illegal goods. This is a very simple problem statement, and if you go through the example, you'd be very much clear that in this case, like picking out this independently is quite optimal. And then you can move these two things out from the left and right side. Similarly, you can have a look at this, there is no point in kind of looking at like going from this way and covering all these three, removing all these three things to remove this one. To remove this one, you can just simply delete it or maybe take it from the right side. So 2, 2 and 3, best is 2, right? So we need to solve this for a length of 2 into 10 to the power 5, which means that length is pretty high. I mean, it's around 10 to the power 5-ish, so we can do something like n log n kind of thing, right? And the strings can be only 0 and 1, and we need to remove all the ones. Zeros can be left over in the string, right? So let's analyze this problem and let's try to see how we can solve this. Very cool problem, and how do we analyze this is also important, right? There are a few observations that we need to make, and we are already done with our reading phase, as we know that we have these 5 phases, and then we are kind of right now in the solving or like observing phase, right? Observations. So let's make some observations. So let's say there is this particular string given to you, which is somewhere over here, right? And there are a bunch of zeros, ones, zeros, ones, and then some bunch of 1 zeros, 1 1, maybe something like this. So at any point in time, you're gonna remove some, let's say X number of items from the left side, some Y number of items from the right side, and whichever ones are left in between, you're gonna remove those ones like selectively using the 2 move cost, right? These would cost like into 2. All of these characters that are removed will cost you X, and all of these will cost you Y, all of these moves. So essentially, if you see this problem, there are 3 different stages in the whole array. One is where you have remove from left, okay? Then there is a stage where whichever characters you see, if it is a 1, you will remove it directly by taking a 2 cost, right? And then there is a stage where any character that you see, you're gonna remove it from right, okay? So there are these 3 stages that are there in the whole array. Depending upon the choice that we make, it might be that we don't remove anything from the right, or we might not remove anything from the left, or we might not do any move like this, right? We might not have this stage altogether. But in total, there are going to be 3 different stages. One where you are like kind of removing characters from the left. Then after that, you will see that, okay, it's optimal at this point. Next, we should switch to the mode where we're going to pick out things in between. And then we're going to move to a place where we remove things from the right. The way this question is set up, it's never optimal to maybe like go through till this part and then remove something directly in between, right? Because if you are removing something from the right side, there is no point in picking out elements in between and paying a cost of 2, because they would have been removed in cost 1, right? So there are these 3 segregated stages in the whole process, and that's what we will leverage out in DP. Okay, so we will do a single pass kind of a DP wherein we will pass in what stage we are in. Okay, and based on that, the cost of every element will be determined. Okay, so let's understand this setup in a detailed way, right? So let's say 1 1 0 1. Okay, and then there is bunch of zeros, and then there is a 1, there is bunch of zeros and all, and there are a bunch of ones, right? So if we see this particular setup, the ideal way to maybe solve this problem would be to go till this point in phase 1, where you remove everything from the left hand side. Then you process all of these characters in phase 2, where you just selectively pick out this and this with a paying cost of 2 2. And then you move to phase 3 over here, where you move out all of these characters using paying a cost of 3. Over here there were 4 characters moved, so total cost paid would be 4, and overall the total cost for this problem would be 4 plus 4, I mean 2 into 2 plus 3, and that would be equal to 11. So that's the cost for this particular string. And as you can see that from this stage we are moving to the next one, wherein we can remove something, and then at the final we are going to move to the right movement part. So let's denote them with a different kind of a configuration. So we will kind of create a configuration graph wherein we start, okay, with pick things from left. Okay, then we at some point in time we're going to move into this state. Okay, this is actually a state diagram. If you know about state diagrams, you might be able to relate with it. We start with this. Okay, there is the start over here. Okay, and then at some point in time we're going to switch to a mode where we're going to only pick elements out of with a cost of 2. Okay, let's say I'm just writing it as P, wherein pick you out with a cost of 2. And then at some point in time you're going to choose that, okay, I'm going to move elements from the right. And then after that, like if you remove one element with right, everything after that needs to be removed with right. So you're going to stay over there, right? So this is the kind of stages that your whole flow is going to go in. Like your choices are going to be somewhere in this particular stage whenever you go through the whole element. So what we're going to do is we're going to keep a DP based on this particular diagram, right? So we said that we have this diagram wherein we have L, we have P, we have R, right? And we start over here, right? So what we do is we're going to call something like, and let's say this is the string S, and there are these positions over here. So the way we're going to write it is in form 1, which means that we're going to be putting a bracket like over here, and let's say we are currently at a particular position I. Okay, so dp of I means we are left with the string to process the string from the position I till the position, let's say n, right? All of these things have already been, like whatever ones were there, they have already been deleted. You don't need to worry about that. If you had to only delete the string from I till n, how would you do that, right? And alongside that, you will have to keep an extra information that in which stage you are currently in. So you will keep an particular marker over here, that last characters stage, like where the last, like what did you do with the last character, right? Because if you know what you did for the last character, you might have an option that you can do the same thing with this character, or you can move to the next stage for this character, right? Or you can even move to the next stage also. But there are only 3 stages, so you can like kind of neglect off one of these stages and kind of process in any one of the 2, right? So this is the whole kind of formulation that we will keep for this. Which particular, like this says that you have to delete the string from S of I till n, right? And the last character was deleted by which move, either 0 or 1 or 2. That 0, 1, 2 will be there in the state of this last chain state, right? Last character stage. Once you know this, writing the transitions are very, very easy. How? You just look at this diagram and try to formulate the stuff. I'm just going to remove this off so that I can write it over here itself. Let's say, so there are different cases. Last chain state was, let's say 0, which means last was removed from L. It was 1. It was 2, right? If it was 0, so let's say you removed the last character from this side, right? You could remove this character also from this side, right? So in that case, there are two particular things that we need to do. One is it 1 or 0? So this is the first choice, that what is the last character. Then the next choice is for each of them, this is how you're thinking about transitions of this particular thing, right? That is the current character 0 or 1, 0 or 1, 0 or 1, right? Now when you have a 0, you can actually kind of omit this character and not delete it and then move into stage 1, right? I mean, if you are in left or right, you will have to remove this off. But if you move to some stage which is let's say not really which is actually a pick 1 and it's a 0, then you can skip it off, right? So from the last stage, if it's 0, 1, 2, this is the last stage, right? Then instead of, let's say, choosing off what we are currently having, I'm gonna change the choice a bit. The order of the choice I'm gonna change. We can loop over that. Okay, this particular character, if the earlier one was at 0, this can be at 0, this can be at 1, this can be at 2. Like, you can make this character get removed by 0, by 1, by 2, right? It's the choice. If it's already 1, you can make the current character get deleted by option 1 or by option 2, right? Because you can only move forward in the flow diagram. In this, you can only delete it by 2, right? And the way we do this is, now if this character is 0, 1, 2 or 1, 2 or 2, then how do we move forward? So this is actually a loop in the code, but like right now we're just formulating the stuff. This is the last one, 0, 1, 2. Based on that, what can be my current character's stage? I can only stay there or move forward in the diagram over here, right? And then what we can do is we can think about, like, if you are in 0 state, right? If this character is in 0 state, which means this character needs to be removed off from the left side. So now each of these can have an option that is it 0 or 1? Is it 0 or 1? I'm just writing everyone, but it's actually much more trivial than that. It's not gonna make sense actually to write everything, but still, I mean, since we are doing it in a simpler way, let's write all of these things. So the level of choices that we have is based on which state you are. This is your fixing your state. This is fixing your position, right? So now you have a character, and what happened to the last one. This is where you choose what happens to this one based on which stage you were at the previous one, okay? And once that is decided, which character is this? Is it 0 or 1? Is it 0 or 1? Is it 0 or 1? And so on. Now, if it's 0, right? If it's 0. So first of all, in this 0, when you take 0 in this one, you are already decided what stage you are going to go into. So whenever if you have a 0 character or a 1 character, right? In this case, the current character is going to be removed off from the left. So it's going to incur a +1 cost, right? And you're going to go into a stage that, okay, you are deleting off the current character. dp of I got deleted, right? But you will need to make sure that the characters after that, s of I plus 1 to n needs to get deleted, right? So dp of I plus 1, and the current choice was 0. So it will move to this state, okay? So at I, you chose a 0. So for I plus 1, the previous character stage was 0. For ith thing, you chose 1. So it will go into that. You means that this can actually be a single pick. So if it's a 0, you don't need to pick it out, right? I mean, you don't need to delete it off. So it will be dp of I plus 1, comma 1. For 1, it will be dp of I plus 1, comma 1 as well. But since you're picking this out, it's going to incur a cost of +2 because you are taking it out. For 2 as well, it's moving out from right. So it's going to combine all together, and it's going to be 1 plus dp of I plus 1, comma 2, right? So whenever you have a stage 1 over here, this cost is going to boil down into, like, if you have a 0, then you don't need to pick it out and you can go into this state. If you have 1, then you can always go into this state, right? And if you have 2 over here, then like you'll have to remove it off. So both of these things go into this same state, right? If you have 2, then there is no choice, but all of these things has to go into this state, and that's the final value. So based on what you choose over here, like what was the last character, what you choose to do with this character based on the stages that you are currently in. So see that when you are at 1, the only stages allowed is 1 and 2. If you are at 2, you can only do 2, right? So if you have removed one character from the right, you can only remove from right. Based on that, what are the different DPs? Like based on what you do over here, there is a cost. If you pick it out 2, if it's 0, don't need to pick it out. If it's from right, either 0 or 1, it will have to get removed off from right. So it's 0, and that's all that you write. Okay. So as you can see that it's like the number of stages that you reach is 4 only, and like there is 3 different stages altogether. Like initially it's either 0, 1 or 2. So in general, you can solve this problem in dp of like n comma 3, and every particular stage has like order 3 number of transitions. So there are 3 transitions per stage on the worst case. So in total, it's actually going to be order n in total, right? But the main thing is this particular generic idea makes it very like simplified and like a template-ish kind of thing to apply to many such more problems. Okay, let's formulate this code up and let's try to see how we will actually do this. So I'm just gonna go a bit more deeper on formulation so that you guys get the feel of how can we do this much more clearly, right? That okay, let's say you are at dp of, or let's say we are writing some recurrence function. Let's say you are writing a recurrence and you are at a particular I and the last character was some ch, right? So what you can do is for this particular character, you can choose for like current equal to, you will start from ch and current can go only up till 2, right? 0, 1, 2, current plus plus, right? And based on that, you can simply write if let's say current is equal to 0 or 1. So let's say if current is equal to 1, that means you have the picking one. So in that case, if it's 0, then you get a flow of dp of, you don't need to pick this out, dp of I plus 1 comma current. It's always going to be this. If it's 1, then you have to pick it out directly. So it has to be 2 plus dp of I plus 1 comma current. Okay. If current is equal to something else, let's say 0 or 2, right? So in that case, it has to be removed for sure. In that case, we can simply combine this off in writing. You will get a 1 plus cost, the dp of I plus 1, and whatever you did with this character, that's going to be passed on. So that's the all code that is going to be there for this particular thing. And across all of these options that are there, we forgot this to kind of combine. Across all of these choices that we have, based on whatever there is, you will have to take a minimum because we want to get the minimum cost, right? So out of all of these things, like this is one option, like this is just an if else, so either of these things will be picked up. So out of this all for loop, whatever is possible, you will have to pick a minimum, right? Whatever is the minimum value that it returns is what you return from this recurrence. And then finally, you'll have to memorize it and all of these things. In the last video, I talked about how do you write structural code for these things. Base case would be simply I when reaches equal to n plus 1. In that case, you can simply return like when ch is equal to it is independent of ch actually. When you reach this, you can return 0 cost after that because you have already handled everything before that, right? And correspondingly, you can solve this problem, right? But the main thing was, how do you maintain this staging idea that left, then pick, then right? That's the main idea, okay? Let's quickly do an exercise and try to see how this can be extrapolated to more such problems, right? And let me give you some glimpse of how generic this idea is and how can this be used in some more good problems. Let's say we are given, let me give you a problem. So this is a new problem. I don't know whether this is there somewhere or not, okay? Let's say there is an n sized array given to you, right? I mean, array problems are very, very common, okay? And you're given a number k, right? And you have to choose k non-empty subarrays such that the sum of those subarrays, k non-empty subarrays, such that sum of those subarrays is maximum. And let's say exactly k, okay? You have to choose exactly k subarrays where the sum of those elements is maximum, right? And just to give you an instance, like if k is equal to 1, then this is actually the K-Dane's problem, right? You have to find the maximum sum subarray. If k is equal to 2, you have to find 2 different subarrays and then add their, like this array's all elements sum plus this array's all elements sum all together has to be maximum. If k is any generic number, you have to find the maximum sum across all different k's. Like you can choose k different subarrays in the array. Disjoint, let's add a new term, k disjoint, okay? You don't want to count one element multiple times. K disjoint non-empty subarrays. and exactly, which means two subarrays cannot be like this. You cannot take this one as subarray and this one as subarray because they will get merged, right? So the way we do this is this maybe this can be a suitable subarray. So I can fill in some values, 1 2 3 -1 -3, and then 4 -1 5 6, or let's say -6. So in this case, the optimal way would be to pick these two subarrays, right? If k is equal to 2, then this is the optimal solution. Like you pick two subarrays over here, and that's the best sum you can get, right? And in fact, let's say that the input is a generic k. How do you solve this problem? And the way we can do that is very, very similar to what we discussed in the last problem, that we can keep a flow diagram that, okay, 0 means, so you can see that there are different stages in this whole DP, whole selection as well. Before first subarray, after first subarray, second subarray, after second subarray, and so on, right? So like what we can do is we can create a flow. Right, and then let's keep this one like k, and after that there is one more. I'm just gonna move this off a bit on this side. I hope you got the point, right? So what we can do is we can not choose something, but when we want to start taking the first subarray, we will move into this diagram state, right? Wherein we will keep taking the elements as long as we want, but whenever we want, we can switch to the next one, right? And in this case, you cannot really jump to every next one. You can just go to the next one, right? So we can simply write like a DP of which position we are at and what stage we are in, right? The current stage of the last one. So from this, we can choose that, okay, we can remain in the same stage for this element, or we can go to the next stage if we want to. Stage +1, right? And we can like stop it at this particular place. So you can see that if there are k elements, then there can be 2k plus 1 number of states, right? But in total, there are these many stages, and for every state, you have two choices, and based on that, you can do some optimal choices over there. And in total, you can solve this particular thing in order n into k dp. But the thought idea is very, very interesting, right? Because it makes it so simple to think about this problem. Had somebody given me this problem with k equal to 3, and I had to randomly think about this array problem without this DP structure into it, it would be fairly difficult to think about it, right? If k is very small, it is already order n-ish, and if k is a dynamic thing, then you can solve it in order n into k, which is the most optimal you can do. So this is the power of this particular technique. Make sure that you kind of write down what do you learn from this particular video. I will leave this particular problem and try for you to try and maybe give an input for this one. I will search off if this particular question is already there somewhere. Maybe I will create it off if if possible. But again, no guarantees right now. But do check this out, this particular technique. Do try it out. Do solve this problem with this technique, and you will learn a ton in this particular technique, right? So this is the staging DP. I hope you learned something from this particular video. Don't forget to like and comment down what you learned, and definitely subscribe to the channel for more such things. This is the third week of this Leetcode Weekly. We're gonna move forward with more such problems, more such good problems, and I'm gonna try and generalize more such techniques that you can use for so many such problems, right? So that's all for today. Thank you for joining in. Bye bye.